Lesson 6, we enter in a brand new window, the Animator. This lesson will be mostly concentrated in Unity, manipulating the Animator, transitions, parameters, layers, and how they blend together. The player has a new animation box controller script attached, which has a jump curve, animation curve attached to that. So this curve says, by the time you go from 1 to 0, how long you can hold down your jump button. Instead of going from 0 straight up, in a linear fashion, we're going to ramp that up. So if you hold on the button for a very short time, you're going to get to a high jump speed much quicker. And of course, you can change this curve. I have some presets here. These presets are for the movement. So this is the one I found best for the jump curve. So that's the one I kept. So we'll see the presets for the movement in a moment. So here we have our new animation box controller with the one new field. We still have our spawn Y-limit script, hasn't changed. We still have our push controller and one new component on our player, the Animator. The animation input is our regular input that we've gotten to. Let's get into scripts here. So we'll see how far we've got with that in level 6. An animation, lesson 5, an active input. We're able to enable and disable the input from the user. Now, in our animation, we define how we move from left to right. Just like the jump curve, if we hold it down, we, in a linear fashion, go from 1 to our maximum speed. Or we can set some presets that this one goes a little bit slowly and then it ramps up. This one goes a lot slowly. So you have to hold down the movement direction for quite some time before it gets to that point. And that one's more of a smooth curve. So you can experiment with those. We'll see how those work in the code in a minute. Then we have the move threshold. When do you want to start moving? Right at when it gets to maximum speed or anywhere in between? We still have our static game board, which we are going to address, I believe, in the very next lesson. We have our checkpoint, a pushable cube, very familiar items by now. Our goals are still the same with our pickup and broadcast scripts attached. This was just for me in testing. It's an easy goal. Place somewhere where I didn't have to work hard to get it. And we still have our persistent game controller, which loads new levels now in its cycle. Right? Okay, so now onto the player and its Animator. We have a player idle, which just keeps the player static, does nothing. We have the player left, which turns the player from 0 to left. That's on its rotation. It's inheriting in the hierarchy. Okay, so we have the model rig and the model, which we're transforming. Right corresponds with left, but in the other direction. We have the headband move. So when the player is moving, let's get into this scene here. The headband would be doing as such. So I think I can just press play to loop that. Yeah, there we go. So as the player is moving, we'll see that on the headband. When the player jumps, This is on the ground beginning to jump, so we'd assume the headband would be down. And while he's in the air and he's falling, it'll transition between the falling and the totally grounded. And those are the animations that we use. Onto the animator. So in our initial, we have entry state go into the idle, which we saw. We transition from the idle to moving left or moving right on parameters. We have a move direction parameter set. Let's go into those. We have a move direction X and move direction Y. And we have a direction X. Parameters give you a few choices: float, int, bool, and trigger. We use them all here. These are float values, and this is a trigger. I think the triggers provide the circle. That means it turns on and Unity turns it off right after it's turned on and used. That's important. And this is a Boolean value, either or. We can set either state. You can only set a trigger to one state. You trigger it and it's in that state for on for one cycle, and then it goes off. Unity takes care of that for us. So in order to transition to the left movement, we have to have the condition of move direction is less than 0. So we're moving in the negative direction. To go to right, we do greater than 0. Or if we're in any of these states, we can move directly into the next state. So if our move direction suddenly goes from less than 0 to greater than 0, then all of a sudden now we can just go directly into this state. We don't need to transition back. And it works for the other transition as well. I also implemented here a blend tree. The blend tree does this same action, but it provides a little more visibility on a device when you're moving. So let's check the headband layer, and then we'll go into the direction blend tree. So here in the headband layer, we do much the same. We have a regular state machine that runs, and the condition, we have 2 set this time. If our move direction Y, that's another parameter we have set. If that's less than 0, then we're falling. Now if it's less than 0, then we're on the ground, and we haven't began jumping yet. Right? So if so, we start the jump begin. Again, this is the trigger. So once this activates, it goes into this state. To go into the headband end, we need to be not grounded, and that can be set in code, which it will be, and I'll show you where and how. And our move direction also needs to be headed towards the ground, less than 0. Gravity needs to have already started acting on us to the point where it's drawing us downwards. Right? Again, with this defines grounded in a loose sense, right? Where gravity's pulling us down, our y direction is less than 0. So our headband has ended when we're not grounded, and our gravity has started drawing us back down. And we switch into our headband end state. And going out of both of these states are a little bit different. So if we're not grounded and the transition is over, the exit time, we don't use that. We just go through the entire animation, and when we're not grounded, we just get out of there. and that's almost instantly. And as you remember, the headband begin animation is just an idle animation with no movement of the headband. The headband end, however, we do use the exit time, so we let the transition play all the way through. We're on headband end here, so I can show that. So it starts here, and it will transition, by the way, from being down completely to up. It won't snap. That's what the animator and the transitions and all those things do. And then as you hit the ground, it goes into this state. So that's what this animation part does. So we go back to layers, and our base layer also has a blend tree that I will show the movement of. Let me do that right now. So generally we're using this one. So now we move left, we can see the character turning left and right. But pretty much when you hit the key on the keyboard, it ramps up so fast that it gets to left and right really fast. So providing a transition with a length gives us the animation ability. Okay, so now let's make the blend tree our default transition. You can see it's more snappy on the keyboard. But when you build it on the device, if you tilt the device a little, the character will be tilted a little. And if you're moving at maximum speed that you can tilt the device, it will be rotated completely in these directions. So it provides a little bit more feedback. So let's check out that blend tree. So we set up 3 already existing animations. We add 3 motion fields, and we populate them with the corresponding animations. The thresholds correspond to the speed of the player. Maximum speed 6. We'll set our thresholds to -6, moving left, negative direction. +6, moving right, positive direction. We'll play the animations at their normal speed. So when the player is moving completely left, it'll be showing that animation completely left. When the player is moving completely right, it will show that animation completely right. Now for the headband, we also have a blend tree. Now if you remember, the headband has a few states, from jumping, blending, the idle state, which if I can show in here, gives you some of that, and the idle move state gives you that. So we need to get between those two. Stop that. And that's what this blend tree accomplishes. So it will blend from, if we're moving in the either direction, left or right. You'll notice we use the same move headband animation here, we just provide a different threshold. Again, at the maximum speed that we could move, it would blend in between the normal idle, where the headband's moving up and down, into where the headband's moving up and down between the idle, which is the move. Okay, and that's accomplished by setting the blending of each of these to this particular value. I've tried them both. I'm not informed on every single thing on here. As a matter of fact, I tried clicking a few of the other ones and had no effect on what I was trying to accomplish, so nothing worked. So what did work for me, I can't set the weight of this one. It's the base layer always is in charge. So I set this to additive. So I want whatever's happening here to be interpreted, I guess, by the base layer as being supplemental. That's the best thing thought I could have come up with. But in this state, I'll override whatever's coming in with a weight of 1. And this is the only setting that I got to work the way I wanted. If you adjust the weight, the headband won't move as much when it's transitioning from the base layer into this layer. For instance, from just standing still or turning to the headband actually moving up and down as it floats. So this can be adjusted to taste, but one maximum was what looked really good in my eyes. So that's the layers for the blend trees, and let's see how we set those in code. So we'll start off with the animation input controller, which has now been turned into a component. So we have input that we can add to a game object and manipulate. We declare it static, as our input controller was static from beginning, and if we need to access anything in there, it needs to be done statically. But we do have a private function here, a private field here, which is serialized so we can access it. Is animation curve. So we set it off to a new keyframe. This is, I think that gives it a little curve. Play with it. You can set all kind of keyframes to make your movement just the way you want it. We set the move threshold with a range. We set our instance every time. We don't care if this is reloaded 1,000 times. We just want this object, you know. So there's no don't destroy on load or anything like that associated. And we do our move direction. So we needed to change the way we move. So again, the curves, you know, if you hold for a shorter period of time, it will get to the maximum speed much faster, depending on how you set the curve. So you can use that here. You get the move curve, and you call the evaluate function, and it takes the current time from 0 to 1. So our move direction from here is a value from 0 to 1. Remember, it's normalized. And it will give us that curve, whatever we like. The curve, the linear transition between 0 and 1, or the curve transition. This is where it does it. And then we normalize it again, just in case. I'm not sure. You can remove this line, fine. If not, it's there for safety. Then we do that also on any other device other than the Android, in my case, again. Okay, then normalized again. If move direction, okay. So I can, this one can be removed because it's set out here after it breaks out of each of the switches. Alright, cool. I do that. So now that's our input controller. Now we can attach it to a game object to adjust our curve, our movement curve. Now on to our animation box controller, the character controller. We implement much the same thing, field as the move curve, but we do it for the jump. So how long do you want to hold down the jump button before it gets to where it needs to go, and how fast does it do it? We can adjust that curve. So in our box controller, quite a few things is done in Start. I don't even know if in Awake. Okay, so the class does not allow for overriding the Awake. So we get reference to our animator in the Start. We override the move input. Remember, this is the controller, so we can override the move input and give it a value of what our current move is, which will be now the curved value. We override our get jump input so we can trigger from our animator when the jump has began. We can set the trigger to jump began. I'm actually going to look for it so you can see all the sets that they have. Okay, this is exact naming from animator parameters to these string values. Alright, cool design. Pull them out, because these things, fixed update, this is being called every fixed update and it creates a new string. It can be a constant. Let me not talk. Action, huh? So let's do that, and let's give them okay, anim move direction X, and we get the value of that. So we have 5. Looks like about 5 right there. First is jump direction. Might as well start there. Jump began. Then we have move direction X and Y. And just the regular direction and is grounded. Alright, so is grounded. So anim. So I'm gonna give these a prefix of params. So on in Visual Studios, you hold down the Alt button and you select, and you can drag and enter in all the lines. So that's the params name that we're gonna be using. Whoopsie daisy. So now we can set those. Jump began will be jump began. Move X and move Y. Direction X. I do a lot of copy and paste on these because I know my copy and paste patterns. So I know I would have copied the X to make the Y. And if there's any change in the naming, or the mistakes won't be copied over. I rarely type what I don't have to type, because I used to program in text pads, man, and you didn't have all these fancy things that tell you when you're making mistakes. And even now with strings, you're still in trouble, so you still have to be very wary with strings. That's why it's a good idea also to create constants and static access to strings. That way they can be defined once and used over and over again without misspelling. Okay, so now we've created our constants. So yes, so now when jump began, so you get the jump input from the base class, and that will tell us when the jump began, when the key is being held down. And if that happens, we set that trigger in the animator, and then we return the jump has began, or not, depending. So in the fixed update, we set a few of the animator. We set floats for the move direction, which says exactly what the value of our move direction is. This is not normalized. The X and the Y, and rounds it to an int to give us our integer direction. I needed these two while tinkering around trying to get everything working right, so that's why I have a float value and an integer value. Float values won't let you set equal to. Integer values will in the animator, so I needed this one to get all the transitions working correctly. Then we set the bool if we're grounded. So at every fixed update, it sets our animator whether we're grounded or not. And we perform our jump actions, right? So if we're grounded, if we hit the ground jump action, right, we still call our base, which sets our jump speed, and the ground jump action is the return from the analog jump, from holding down the key and it accumulating over time. And that time it accumulates over always evaluates to the max speed. It can never exceed that. So we can divide those and get a value from 0 to 1. And then we pass that into the jump curve, which evaluates time. So it's a 0 to 1 value. And that jump speed we set in our base class by passing it in here, and we're good to go. That's for the ground jump, and the same exact action for the wall jump. You know, I'm looking at this. We covered lambdas already. Yeah, we did. I was gonna turn this into a quick lambda, but we already have, so you can if you like. So that's the only scripts that we have. And again, code reuse as much as we can throughout these lessons. So after doing all of this animation stuff, we luckily got to write some code. Alright, you know, so that's what we came up with. And we can play our scenes from what's selected in our game controller. Animation has not been, this always comes up, I think, when I'm switching between those and clicking on and off the transitions and everything. Every time I go to select through them, this always came up, but once I hit play, it goes away and it's not an issue. I believe it's an issue with the animator not being selected, and when the scene reloads, it's, I don't know. So if it happens to you, then that's why. It's not a problem that stops anything from working. Right, so we press play and we see how our little animator works. So the next lesson now would be level creator, and that's where we do a lot of fun scripting. So we'll do some scripting in the runtime side and the editor side. Cool, so if you stay tuned for that, we would the next lesson do exactly that. Watch my animator as I try to pick these things up. We'll create a 2D environment in the scene view and create scene handles to select and deselect sections along that grid. And each of those sections will be able to change the type of it. So whether it be a wall, a pushable cube, a pickup, spawn point, checkpoint, and once we're done with that, we'll build a level creator that will generate the level for us so we can play it in the scenes. So that's next in lesson 7. Why is this thing so hard for the creator? Okay, our Box Ninja is, I don't know if he's a little smaller than 1, that's why he's able to fit between those things.